Hello, this is Tom, and in this video I'm going to show you how to use the G75 can cycle to rough and finish a groove on a CNC lathe. In a previous video I showed you how to use this same G75 can cycle to groove multiple grooves in a row where the groove was only as wide as the tool itself. In this video I'll show you how to use that same G75 can cycle to rough and finish a groove wider than the tool used. Let's see how that's done. Alright, so for this example we're going to be using a 1-inch piece of stock, and we're going to be grooving this 200 thousandths wide groove down to a diameter of 700 thousandths. The right side of the groove is at 200 thousandths from the front face, and the left side is at 400 thousandths from the front face. So let's take a look at the simulation and see what the process looks like. Alright, the operation starts with the tool in position to do the first plunge cut at about 50 thousandths above the part, and then it's going to feed in 40 thousandths at a time and then retracting 10 thousandths to break the chip. It does that on both roughing passes. It leaves about 5 thousandths in Z on both walls and then 10 thousandths on the floor for a finish pass. And then you can see at the very end it just comes out of that corner just a little bit, just enough to do a retract move. Alright, so let's take a look at the code and see how the G75 can cycle is used to rough and finish. Alright, so for this operation we're going to call tool 4 and turn the spindle on to 2000 RPM. Then we're going to wrap it to G54 Z minus 330. Now remember, the tool is 125 thousandths wide. The right side of the groove is at 200 thousandths from the front face. So 200 thousandths plus 125 thousandths tool width plus 5 thousandths for finish puts us at Z minus 330 for our first rough pass. Then we're going to wrap it to X 1-inch 100, so that's 50 thousandths away from the part, and the M8 turns the coolant on. Then the first line of the G75 can cycle only has the retract value, which is the R.01. So after each 40 thousandths depth of cut, we're going to retract 10 thousandths just to break the chip. On the second line of the G75 can cycle, we have an X value that is 720. Now the groove finishes at 700 thousandths, but this represents the roughing diameter. And then the Z minus 395 is the second pass that the groove tool is going to make, leaving 5 thousandths on the 400 thousandths wall, so there again leaving 5 thousandths for finish. The P400 represents 40 thousandths, and that is the depth of cut, or the packing depth, and most machines don't allow the decimal, so therefore the decimal is moved 4 places to the right, and that's how we come up with P400. The same for Q1000. It's actually 100,000 step over. It probably won't do 100,000 step over because the groove is not wide enough, but it represents the max step over. Alright, so then the F, of course, is the feed rate for the operation. So at this point the groove has been roughed, leaving 5 thousandths on both walls and then 20 thousandths on the OD. Then right below the G75 can cycle is where all the code is located to finish the groove. So we wrap it to X 1-inch 100. We wrap it into position to finish the right side of the wall, which is now at Z minus 325. Then we feed to X 0.7, our finish diameter. Then it rapids back to X 1-inch 100, rapids to Z minus 400, which is the left side of the groove. Then we feed again to X 700. And then we just pull out of the corner 10 thousandths in X and 10 thousandths in Z away from the finished wall before retracting in X. So you can see that the G75 can cycle in this instance was only used to rough the groove. So that is the difference between the G75 explained in the previous video and this video where we actually use it to rough a groove. Alright, so that's the end of this video. I hope this information was useful to you. If you have any questions, leave me a comment, and thanks for watching.